Mark Schnepel, welcome to the podcast.
Thanks, Peter. It's a pleasure to be here.
So, Heat Recovery Innovations, that's a cool name. And the company spun out long time, long history from Ingersoll Rand, which of course is a big brand name. Would love to hear more about it. Tell us about it.
Sure. Yeah. Our origin starts in the late 1990s with Ingersoll Rand. We were developing a series of small gas turbine generators. And one of the vital components of a gas turbine is a recuperator. It drives efficiency. These are high temperature heat exchangers, recuperators. And Ingersoll went out to the market and really could not find what they were looking for in terms of fit and cost. So they decided to vertically integrate and bring the technology in-house. So we've been at this for over 20 years, developing high temperature heat exchangers for now a variety of end markets beyond just gas turbines.
Very cool. So, a lot of our audience is renewable energy focused, right? So, when they hear stuff like gas turbines, heat exchangers, they don't necessarily know exactly what it does, what it's used for. If you could you back up and go like layman's terms for the non-engineer, tell us what those heat exchangers were used for in the past, and maybe what new applications are heat exchangers used for now.
Sure. So a recuperator in a gas turbine recycles waste heat. Gas turbines make power off of temperature rise, and you can get that temperature rise through a multitude of different ways. The most common way is to burn a fuel, whether it's natural gas, a liquid fuel, propane, whatever the case may be. But there's a lot of heat that comes off the back of those gas turbines that can be recycled in, and that offsets the amount of fuel you need to burn to get the same power output. So recuperators are efficiency drivers. The gas turbine that Ingersoll Rand made without the recuperator would be about, say, 17 or 18% efficient. But with the recuperator, it drove it up to over 30% efficient.
Wow. So you're grabbing that waste heat, driving up the efficiency. And how big of a gas turbine or how big is this application in terms of size? I hadn't heard of Ingersoll Rand gas turbines.
Sure. Ingersoll Rand formed Energy Systems in the early 2000s. We had two product sizes at first. We had a 70 kW, which launched in 2001. And then we had a 250 kW version that launched in 2004. That 250 kW version was later increased in power output to 333 kW. And then as Flex Energy, the Ingersoll Rand business became Flex Energy in 2011. And under Flex Energy, we increased the size of the turbine to 333 kW. Plus, we packaged four drivetrains in a single ISO 44 container to make a 1.3 megawatt package. All of those utilized the same recuperator technology.
Gotcha. And is it used for maybe remote power generation applications or what are the ultimate applications of these things?
Yeah, great question. It was really three principal applications, and then there was a little bit of an offshoot. But the first was oil and gas. So, turning flare gas into power in remote places all over the world, from offshore to, Canada to, West Texas, down in South America. Any of those places can utilize that flare gas to generate power at site and reduce the flaring footprint, but also provide that much needed power for operations at site. So that was kind of the bread and butter. From there, there was combined heat and power, which is more of a industrial application where, let's say industry, say a medical industry, they make products at site, they use a lot of power, but they can also utilize the waste heat off the turbine after the recuperator for either hot water or for cooling or for steam generation. So that's what we call combined heat and power. So that would be hospitals, industrial manufacturers, big apartment buildings, any place where there's basically a continuous need for power, but also a need for either hot water, steam, or absorption chilling. The last one was biogas. So this was utilizing a biofuel, let's say off of a landfill or wastewater treatment process. And that gas with some fuel conditioning can be used to run the gas turbine and then provide power, to take care of the gas emissions off the landfills in particular. So you can utilize that fuel in a similar way to the oil field where it's a waste fuel and you can monetize it. The last sort of offshoot was what we call the external heat market. This was more alternative energy where, let's say, concentrated solar, or there was some process that had a source of heat, and we could use that heat in place of fuel being burnt in the turbine to generate electricity. And we had applications around the world with that. Again, all of these required that high temperature recuperator, high temperature heat exchanger to drive efficiency as high as possible.
Gotcha. So that's a long heritage of a lot of different applications where these recuperators were used. Sounds like they've been well field tested. So after you guys have spun off, what are some of the new applications that you're seeing in today's, call it, energy transition world that are different from what we may have seen in the past?
Yes, very well tested to the tune of about 9 million hours of field experience on that recuperator technology. But really, the start of heat recovery innovations was back in 2016 when a very large fuel cell manufacturer came to us and asked us to take a look at their applications. Up until that point, we had really designed recuperators for our specific use case. There were some design elements in there that made them not scale up or down very well at all. Some very expensive tooling that was required to change the design for new applications. So we innovated in 2016 and found ways to divorce those design elements from the core technology. And that allowed us to scale that technology up or down almost infinitely. So we made things as small as a cell phone, but also as big as a house with the technology. It's the same counterflow technology that Ingersoll Rand developed back in the late 1990s, early 2000s. But now we're putting it to use in a host of new applications. So fuel cells, molten carbonate fuel cells, solid oxide fuel cells, solid oxide electrolyzers, capture technology, both on the back of power, but also direct air carbon capture, energy efficiency, which is really divided into two categories. The first is what we call clean energy efficiency, where you just have a source of clean heat and you need to sort of recycle that and put that back into your process. But also what we call fouling, waste heat, where something in that flue gas is going to foul a traditional heat exchanger. We have some new technology that allows us to run through that with little to no performance degradation in our continuously cleanable heat exchangers. And then I would say the last is in the transportation industry. We have done some work with some vehicle range extenders and also some alternative engines that can utilize waste heat recovery.
Gotcha. Well, a lot of applications, it sounds like. Of the ones you mentioned, a few stick out. Of course, fuel cells, extremely important in energy transition, carbon capture and storage. We're hearing more about both traditional carbon capture and storage and direct air capture, those kind of scenarios, as well as electrolyzers. And depending on this guidance of the Inflation Reduction Act, we may see a flurry of activity, I think, in the electrolyzer market, turning wind and solar into hydrogen. So maybe talk a little of those applications. Let's double click on those and go a little deeper if we could.
Sure. Yeah, the solid oxide technology, there's a lot of players out there right now. And the one sort of universal constant is they need heat recovery within their system to drive efficiency as high as possible. A lot of these technologies are quite expensive compared to conventional technologies, but they are very efficient. Whereas, your common combined cycle power plant is anywhere from 40 to 50% efficient. These fuel cells are getting up to over 60% efficient, and some of the electrolyzer technologies are north of 90% efficient. So while they are expensive, there's obviously an efficiency advantage there. And what we do is help drive that efficiency as high as possible. The one electrolyzer application that you did not mention is nuclear. There's a lot of work around comparing the continuous carbon-free power from a nuclear power plant to electrolysis in the form of solid oxide electrolyzers. And we're working with a couple of companies that are looking to do just that. And with utilizing the waste heat off the solid oxide technology, as well as some of the heat off the nuclear, energy that's being generated, they can drive up to almost 100% efficient overall. So it's very exciting times for the hydrogen economy.
Wow. And are those the small modular type of reactors or some of the next generation nuclear or more of the large scale traditional type reactors?
Right now, it's the large sort of traditional existing nuclear reactors is where they want to utilize this. But my personal view is that the small modular market is going to blow up here. I think there's a lot of opportunity for small modular nuclear, and that's also a place that HRI is looking eventually to get into in terms of heat recovery, because there's applications there for us as well.
Very good. Let's transition a little and talk about the investment side of the business. I know you guys spun off and have had some investment come to the company. Would love to hear more about that.
Sure. Really, the origin of that is in late 2021, we actually, as Flex Energy, so Ingersoll Rand became Flex Energy, we went out to the market with an IPO. And unfortunately, the market conditions weren't conducive to that at the end of 2021. And we pulled that application back in early 2022. But the main piece of feedback that we got when we were road showing the company was that we had, a very mature turbine business, but then we had this very dynamic and growing heat exchanger business. So we really thought that the best thing to do was to, split the company and really unlock the value of the heat exchanger business. So our existing sponsors at the time gave us a little bit of seed capital to go out and, continue and raise some money. And that's what we accomplished in June of 2023. We received new investment from Coppermine Capital, Nick Stork, who's the CEO of Archaea, former CEO of Archaea, as well as the Salt and Slough Co. And those three, sort of banded together and backed HRI, and those are our sponsors now. So very exciting times. We've used that investment to grow the company. We've made some investments in some capital equipment that will allow us to more vertically integrate and offer, more opportunities for our customers in terms of the products that we are able to give to them. So it's not just the heat exchangers now. We're able to branch out a little bit more with, sort of custom fabricated parts that are necessary for their processes and for their equipment, but they would have to go to someone else. So now we're sort of a one-stop shop for a lot of those customers.
Gotcha. What do you think was the investment thesis for the folks that came to the business in terms of growth of the business, new markets? Sounds like a great equipment business. Is there any sort of potential services revenue? Is there any sort of potential recurring revenue that comes out of it? Or does it tend to be a one-time equipment sale?
It is not a one-time equipment sale. A heat exchanger, like any other component, has a useful life. So our heat exchangers, while they are the best in the business, they are eventually going to wear out. So there is a long-term aftermarket opportunity with our heat exchangers. A lot of our customers have different price points they wish to hit. Some of them are willing to trade that initial cost for longevity. So they want, premium materials, a little bit thicker, can really stand the test of time. Maybe they're targeting a 10-year lifespan for that equipment. Others are a little bit more pragmatic. They want maybe a 5-year life to that equipment. So they're going to go for that, maybe a little bit thinner gauge or maybe a lesser material specification. So that's just going to be a replacement down the line. About 5 to 10 years is about where we're seeing the sweet spot for sort of the OEM to aftermarket side of things. On the service side of things, we do have a couple of designs with a couple of customers that have serviceable components. So we'll be providing those on sort of a more than 5-year frequency. Some of those, they want to target maybe a 2 to 3 year replacement. So we design a heat exchanger. Maybe it's a big heat exchanger that has multiple stages within it, but maybe one of those stages is their Achilles heel. And they're willing to take that at a 3-year lifespan versus a 5 to 10 year lifespan on the rest of the equipment. So there'll be some aftermarket sales there and some service support there. And then the cleanable side of things that we're looking to get into on, the fouling market and the evaporation market, those will have probably an annual maintenance component to them where either our service technicians or somebody else will have to go out and perform some maintenance on an annual basis.
Gotcha. It sounds like a very robust, well-rounded business model. Are you guys manufacturing the equipment there in your location, or you guys outsource it?
Yes, we have a 45,000 square foot facility in Dover, New Hampshire. That is where we're going to be expanding. Right now, we're roughly utilizing about half the space. The other half of the space is inventory storage. We'll be moving that out, and we'll be expanding our manufacturing footprint with automation, with more equipment, with more capital equipment. And we've got would say a 3-year plan to have that space feel fully utilized before we are ready to expand. And we do have some opportunity on that same site to expand by about 30,000 square foot.
That's great. We're hearing more and more of that made in the USA type of heavy equipment. So it's great to hear that. And you say you're up in New Hampshire?
Yes, Dover, New Hampshire. It's about an hour north of Boston, Mass.
Very good. Do you do any skiing? I have to ask anyone who's from up that way.
Unfortunately, I do not. I've got a knee injury from high school that prevents me from doing that. But I have a daughter that is a ski racer, so she competes in giant slalom and slalom. So I'm stuck on the hill regardless. I might not be skiing, but I'm sitting there rooting for my daughter.
Oh, that's great. Yeah, I personally love to get out there on the slopes. I don't think I'm going to make it this year, but hopefully next year. Well, Mark, where do you see the business going down the road as you continue to expand and grow? And if you can talk about it, what is ultimately, do you think, your exit strategy?
Yeah, I see continued growth. I look at our customer base right now, what their plans are, and we are fortunate to have gotten in sort of on the ground floor with a lot of our customers and are working with them sort of, shoulder to grow their business as well as our business. So, as their business expands, as their, products mature and get their way into the market, we're going to be right there alongside them. We add a lot of value beyond just providing a piece of equipment, whether it be a heat exchanger or something else. We basically function as an extension of the customer's engineering team. And because of our long track record, 20 odd years of gas turbine development, we have a lot of experience in cost reduction, optimization, and design. And we work as an extension of that engineering team that our customers have in house. So I expect that to expand. We're going to continue to grow the business. We've just really scratched the surface of energy efficiency in the world. The really thinks that about 35% of our carbon reduction goals by 2050 can be met to the tune of about 35% with just recycling waste heat. So that's just taking processes as they are today and, utilizing waste heat recovery to drive efficiency up. They think that we can meet almost a third or about a third of our carbon reduction goals by just doing that. So the tremendous opportunity out there. We're going to look to get as much of it as we can on that high heat side of things. So we're going to grow that. In terms of an exit strategy, really don't have one right now, really focused on growth, really want to grow the business up. I think there's a lot of headroom here for us, and we're going to continue to expand, add new customers, add more equipment, expand our offerings to our customers, for the next 5 to 10 years.
Very good. Sounds great, Mark. Can you tell the audience how they can get in touch with you if there's any customers out there or investors that might want to reach out?
Sure. You can visit our website, heatrecoveryinnovations.com, or follow us on LinkedIn. We have a Heat Recovery Innovations page there as well. And you'll be seeing a lot of content from us, in the coming months as we, really highlight all of the different things that we're shipping on a month-to-month basis, as well as the innovation that we're bringing to the space.
Very good. This has been Mark Schnepel on Energy Superheroes. We very much appreciate you being on. Thanks, Mark.
Thank you very much. Pleasure to be here.